have it later if you want it. Okay, so here we go. So this is the PowerPoint for it. We are going to look at these 2 or 4 bullseyes. Okay, you notice that it says precision increases as you go up and accuracy increases as you go to the right. All right, so what you see here, Kennedy, okay, hold on. I thought Kennedy, no, she's not on there. Okay, as you look at these, what do you see that's different between the A and C?
A is scattered and C is clustered.
Correct. And that is exactly what that means. You said the magic word, clustered. That means that you can repeat what you've done. Whereas A, you didn't quite, right? Maybe 2. All right, what about between A and B? What do you see the difference here? What do you see that is different between A and B? Nobody?
It's less, A is more scattered than B, and the location.
The location, yeah. What is the usual point of shooting at a bullseye?
In the center.
Exactly. And these are all touching the center. You notice that? The B is all touching the center, which means they are accurate because you met your target. You met what you meant to do. All right. What about between B and D?
D is more, it's in the center, so it's in the target of D,
And
right? And B is more, while it is in the center, it's more
more
scattered.
scattered. Right. But they're still in the center. Okay. So they're both accurate, right? But B is not precise. Whereas D is both accurate and precise. Do you see the connotation here? So let's look at what that actually means. That was just a quick little demonstration so that you can actually see it for yourself. But here's the what they actually mean. What's the difference? Okay, so accuracy is how closely a measurement matches your true or actual values, which if you notice in the lab, I gave you that, right? And in order for you to calculate the percent difference, all you actually need is 2 measurements, the actual measurement and your measurement, or the measurement that somebody else made, you know, what is called the experimental measurement. Okay, so this is the formula right here. So make sure you copy it so you can do that lab. So percent error is equal to the experimental value. Notice this is in parentheses because you got to do this subtraction first, minus the actual value divided by the actual value times 100. That's percent error. Okay. Now, another thing to realize is that with accuracy, we do actually need a true value or an actual value. With precision,
Oh, wait, you could go back real quick?
sure.
I was writing down, yeah.
Oh, sorry.
Okay, thank you.
Okay, I'm doing Zoom because so far I haven't set up my Microsoft account, which I need to, because that's what they want us to use. They want us to use Microsoft Teams, I think it's called. And I don't have it yet, so I'm waiting to hear from that. All right, so anyway, when I do, then that whatever, will change, well, how we meet, but I can't say that I can't do that yet. All right, so precision is actually how reproducible something is. So basically, if you measured something, even though you had a bias or an error, the error is the same every time. Or there's also random error that happens by some random cause. We don't know. But a lot of the times it has to do more from the experimenter's view or the measurement by the instrument itself. Okay. So if something keeps going a little bit more, like heavier, let's say, then if something's heavier, its chances are than the actual, then chances are it is miscalibrated by whatever amount that is. And so every measurement you make is going to be going that way. And that's what is known as systematic error. Or it can have random error, like I said, which is, it happens for no particular reason. We don't know why. And it goes either up or down. Okay. All right. So in this case, you notice that in order to figure out precision, you require several measurements. This is why I did not ask you guys to do the precision. Okay. It has nothing to do with the true value at all, because you don't require a true value in order to see how reproducible your own measurements are. And to calculate it, there is a formula known as percent difference. So percent error is the measure of accuracy of a measurement, and percent difference is the measure of the precision of multiple measurements. Got it? All right, so I'm gonna let you copy that, and then we're gonna keep going. And I expect you guys to answer real quick on the chat when I have some questions, because you'll see. Okay, so you ready? Okay, here we go. We are going to go to the next one. All right. So in the chat, please just put A, B, or C, 1, 2, or 3. Sorry, not A, B, or C. 1, 2, or 3, if that picture represents one of those. It's kind of like a poll, right? But a chat poll. Okay. Okay. All right, there's 11. I mean, there's 10 of you, so I'm only seeing 2 answers. Come on, keep going. I told you that this is an interactive way of doing things, just like if it was a classroom. Thank you. Thank you. Okay, keep going. We need more. Okay. All right. So here's the true answer. Because you have a certain percentage. You have 33% chance of being correct. And if you did number 2, you got it. All right, excellent. Now let's go to the next one. What about this one? 1, 2, or 3? Very good. Got one answer so far. Two. Mm-hmm. Three answers. Come on, keep going. Everybody needs to answer. Good. Okay. Anybody else? Going once, going twice, and here's the answer. All right. So everybody picked accuracy, but it's actually both. Anyone care to tell everybody why you
I
now
think
know?
I just understood why it's both because, yeah,
Okay. Good. Let's go ahead and tell them. Tell them why.
because in the picture that you showed us,
Mm-hmm.
the one like accuracy could be scattered, but it
Mm-hmm.
could be like populated in the target, if that makes sense.
Correct.
So it doesn't
Yes.
have to be clustered in the target.
Uh-huh. And it's pretty accurate and
Yeah.
precise because they're all within the same area. So, and it's a small area. So yeah, the actually the Caden, you're asking me if this is on Canvas. It is already on Canvas. I get it from Canvas. Okay, so see, this is the answer right here. In order to be accurate and precise, one must pay close attention to detail to receive the same results as well as hit the target, right? So you get the same results and you hit the target. So both of them are accurate and also precise. All right, now here's where we're weighing stuff. Now this is a little different, isn't it? This is an actual measurement. All right, so which one of these, 1 through 5, is the most accurate measurement of mass? And you notice that it says a sample is known to weigh, and it gives you the mass, the actual mass. So go ahead and answer. This time you only have 20% chance of being right. Okay. Okay. Going. Only have 2 answers. We need at least half so that we can proceed. There we go. Excellent. 2. 1 more. 2 more. I mean, good. Excellent. Okay. So, of those of you who answered, wait. Okay, I'm waiting. Okay, you got it? All right, there we go. We are going to look at it and see who is correct. You pick 2, you are correct. And the reason that is, if you look at it, 3.180 and 3.182 are only 0.02 away from each other, whereas this one right here is 0.8, 0.08, no, more than that. And then this one, you know, it's 0.3, right? Not 0.03, sorry, not 0.002 though. So that's much smaller. And this one's 0.007. This is the second closest actually, right? All right, so let's go and keep going. Now, the reason it's accurate, like I said, is because it's the closest to the actual measurement, which was given to you. If we couldn't give you the actual measurement, then you would have had to figure out which one was how accurate these how precise these measurements were, and they're not. They're very scattered, aren't they? But one of them is precise. One of them is accurate. Excuse me. I'm trying to say, no, they're not precise, but one of them is accurate. Okay, thank you. There we go. That's what I meant to say. Didn't come out like I wanted it, but there it is. Okay, now we have these data that were obtained for the length of an object. They were measured by 3 students. Which one of these students is the most precise? We have student A, we have student B, and you have student C. You can just say A, B, or C. And look at, they measured it 5 times. So you can look at all their data and then figure out which one is the most precise. Okay. All right, keep going. Need a little bit more. Okay. All right, we have a split decision on this one. All right, let's see. And again, we have 33% chance of being correct. All right, somebody changed their mind. That's good. I'm glad, because it is actually, if you look at it, if you look at the measurements, do not care about how much it actually measures, right? You're just looking at the measurements themselves. And the ones that are closest to each other are those of student A. That is correct. All right. You just entered and I can't see your name. Could you please write it in the chat? Thank you. All right. So, okay. So let's keep going. Let's see what else we got. All right. Now the same data, but this time we want the most accurate work. Accurate. Okay. I have one answer. Yep. Correct. Yes. Yes, that is how it works. Okay. Mm-hmm. Yes. Very good. Now you see the difference, right? This time we do have a target. We have the target, which is 14.5, and we're looking for who is closest to that particular number. And student C definitely is the one that I would pick too. So, all right. And here's the answers to those. Now, the reason that student A has the most precise work is because there's only 0.1 centimeter between the high and the low values. And student C has the most accurate, since 2 of the measurements were exactly at the true value and the other 3 were only 0.1 centimeters away. So, pretty good. Good job, student A and student C. Student C might have had a bias, right? Because even though his work was so precise, I'm sorry, student A, excuse me, might have had a bias. And see, that happens when you're not looking directly at where you're supposed to be looking. And you can get just a little bit over. All right, so let's keep going. All right, so in this case, this is just a conclusion. Obviously, this guy had poor accuracy, right? But good precision because they're nicely funded. This one had good accuracy and poor precision because they're kind of scattered all over the place, but he's pretty much almost in the middle. And then this one's Robin Hood because he split that arrow. So he actually would have won the archery tournament. See, this is why we need to know these things also, because it's not just for measurements. It also has to do with this kind of trial. And this is actually what they do in archery. My mom was champion archer at LSU in Baton Rouge, a long time ago, of course. So I've never tried my hand at it, so I don't know. I don't know if I have that gene or not. Okay, so now we're not going to go into metric conversions today, just going to skip for now. As well, not that part, because we need to learn more about it. So we're going to go back to modules and see. Okay, so let me show you where these are. You were asking about, is it here? Yes, it is here. And it is under accuracy, precision, right here, see, and measurement. And right here, there is, this is a link so that if you ever want to go look at it more, more, there's that. And there's errors in here too. And we just did this one. We did accuracy and precision. We did skip all this other on purpose. Okay, so now one of the things I want you to look at is the metric prefixes and units. This is a chart that I made that I give you. Wait, that's not the chart. That's the PowerPoint. Oops, nope, that's not it. Sorry, wrong one. Let me go back. I thought that was the chart. That's the PowerPoint. There is a chart in here somewhere. Ah, there it is. Metric conversion chart. Should have looked at it first, huh? All right, so this one is something that you'll need. So if you have printing capabilities, print it as soon as you can. If not, I'm going to see if I can print it at work when I get there Monday. But if I can't, then we'll be referring to it a lot, though. I mean, a lot. And this, the reason I made it the way it is, it's an interesting chart. The reason I do it this way, and I know there's some blank spaces. Okay, go ahead and leave Desiree and Alexa for your soccer. And Caden for track. We're almost finished anyway. This was just a quick introductory, but you saw where it is. So if you can and do have printing capabilities, go ahead and print it, please. I'll be bringing some, but I can't guarantee because I don't even know where to go print in the building myself. So if Dr. Gorski's there, she'll show me. And I'll bring my copy of it so that you guys can have it. Okay, so this one right here has every prefix from PETA all the way down to ATO. And I know that's a lot of prefixes, but I wanted you to have as many because I don't know if you know, but you go to buy a computer right now and they have terabytes. Do you want to know how many bytes that is? Of course you do, and that is 10 to the 12th bytes. So if you have 2 terabytes, you have 2 trillion bytes. Doesn't sound like much. And the next step is the PETA. We're going to be in the PETA region. So that's why I put it there. And then as far as a lot of you are in the sciences and probably in the biology area, and you have microns, which are micrometers. We have nanometers. We have picometers, femto. There's also something known as a Dalton, I think it is, which is in between, but I don't talk about those because I'm just doing the chart that's going by threes at this point. And then there's the smallest, which is an atto. You notice atto is 1 quintillionth of a meter, which is tiny, 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 tiny. But if you're ever looking at maybe someday you do graduate work or whatever, and you're using an electron microscope and you're using a transmission electron microscope, you will be able to see the nucleus of an atom. And that is in the atto range. So that's why I do that. It's not that I want to know everything. I do, but but it's useful. In other words, it's not just for fun, right? It's useful. All right. So knowing that, what I've done is I've given you the value as a meter. So basically, this is how many meters. Peta is 10 to the 15th meters. And here's the actual name, there's a quadrillion. And then the abbreviation is a capital P. And then I gave you the length, mass, and volume, because you got petameters, petagrams, and petaliters. And I doubt if you'll see petaliters, but you never know. You never know what your business will be. Maybe you're a I don't know if there would be that many gallons of oil. No, I doubt it. So, I don't think that this will be, but you never know. You never know. Maybe you're trying to measure the volume of the ocean. Then in that case, petaliters would be in there, right? Of all of the ocean on Earth. So, but chances are you're gonna not get there unless you are a marine biologist or something like that. Then in that case, maybe. Or even a geologist would need to know in the petas. Okay, so, and if you are, and if you are an astrologer, not astronomer, you would probably want to measure in the petas also, because that's very, very far away. All right, so like I said, these are important. Now, I have a mnemonic device that I use, and I'm going to go ahead and I'm going to insert a column in here to give you that. Oops, not to the left. I'm into the right. What did I do that for? Okay, I'm going to insert a column to the right. There we go. All right, so this is your mnemonic device to remember the order. And a lot of you might remember King Henry something. I cannot remember that one, so I just do this one, kangaroos. And then this one's hop. And then the next one is down. This is under. And down under is what they call Australia, so it kind of helps to remember. And this is during cold months. And this one, I'm going to make it a different color so that you realize that this particular one, let me make it purple so that we'll have the Wiley colors. I can make it purple and white though, so I'm just going to make it purple and black. So the purple is the ones that you are going to, why does it have a capital H? I don't want a capital H, it's just a word. All right, so these are the ones that you're going to use when your units go by ones. See how they increase by 1, 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, then 10 to -1, -2, -3, okay? But the ones that I'm going to put now, which I'm going to make them yellow, I'm going to make them LSU color so that way you actually see the difference on these. They are going to be the ones that go by 3s. So I know it's a weird thing, but I found this on the internet, and for some reason it stuck with me. So, oops, sorry, GUI. I know, pretty true GUI monsters. I know this is like the silliest thing in the world, but monsters. And like I said, this is when you go by 3s. So we are going to, oops, no, don't do that. Okay. I wanted just to highlight these, but apparently I can't. Okay, there we go. I was going to make them yellow, well, kind of gold, like maybe that color. Maybe this color so you can see it better. You think that's a better color? Yeah, that's a better color. All right, so pretty true GUI monsters that Peta, Tera, Giga, Mega. And then the bottom over here is May, not, pick, fruit, at all. Okay, don't put a capital, but I don't want a capital there. All right, so there you go. So that's how, when you go by threes. So now here's the kick, the main thing about how to use this. If you are using it, just anybody, pick me something that you want me to convert from to out of this particular, out of this particular chart. What do you want me to convert from to? I was trying to make it smaller so that you could see more. There we go. So you can kind of see it better. There we go. At least you can see the majority of them. All right. Just convert something. Just say mega to whatever, or giga to whatever, or femto to whatever. It doesn't matter. I'm just going to demonstrate how quick you can do this using this chart. Just do a quick, you can speak it or you can write it, whichever one. It doesn't matter to me. Okay. Well, since nobody's doing it, nobody's asking me. I wish you would, because, you know, it makes it easier for you to understand that if you were the one that originated the problem. Okay, so let's say I'm doing, and I'm just going to highlight the one that I'm doing. So let's say I'm doing giga, because you can see that one. And we're going to go to pico. How's that? Okay, so there are three ways of doing this. You can do giga to pico by looking at the numbers that are there. And to do that, you take 10 to the 9th, which I'm going to write with my finger, right? So basically positive 9, right? And negative 12. When the numbers are different in powers, you are going to add them. So that's going to be 21. So whatever you had, let's say it was 5.6 gigameters to picometers, then the answer is going to be 5.6 times 10 to the 21 picometers. We're going down, so then the exponent is positive, okay? All right, let me erase that and let's do it backwards. All right, say you now wanted to go from the same, but you wanted to go from picometers to gigaliters. All right, so now we're going up, right? And then the exponent is going to be negative, but the answer is going to be the same because the distance between them is the same. See, that's gigameters, that's a G. It's hard to write anything with my finger. So you see how easy that is? Okay, the other way is to count. Simple enough. So let's count. Let me go ahead and stamp it as I count. So let's do a start. Okay, so we count the one where we don't ever count the one where we start, because that's like where you're standing. So you never count that step, right? So we're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. You see that? Also countable. So if you're going from giga to pico, then it's positive because you're going down. If you're going from pico to giga, then it's negative because you're going up. That's it. So that's two ways. I know I told you three, but the third one we're going to look at another day. But this is how you do this. It's pretty simple. Basically, you just have to give it that one thing. Either you count or you add. Now, the other thing I'm going to tell you is if you're doing the adding and subtracting, because there is subtracting, let's say it was giga to kilo, okay? We're leaving this 5.6 still. So that is not what matters. What matters is the actual answer, okay? So now we're going from giga to kilo. So let's put another highlight, a different color, let's say green. All right, so we're going to kilo. All right, now we're within the same numbers. So now we have 9 and 3. We do not add these because that would give us 12, and that is not what we're doing here. So if they're the same magnitude, we subtract, and that gives us 6. So then that would be 5.6 times 10 to the 6 kilometers. You see that? All right, let's count them. Let's undo these stamps. Let's see, clear. I'm going to clear everything. All right. All right, so we're going to undo the stamps. So let's redo the stamps now. Let's do checks. Okay, so we're going from giga to kilo, right? So 1, 2, 3, 4, 5, 6. You see that? So if it's the same sign, subtract. If it's different sign, add. It doesn't matter if it's negative or positive. What matters is the direction that you're going. Let's say you were going kilo to giga. Well, in this case, it's -6. All right, so positive, again, one last time. If you're going down, oops. Yeah, I like the thing, but I don't like that it's not letting me make my arrow. Then it's positive. If you're going up, then it's negative. Got it? Pretty simple, right? All right, that's it. You may go. I am done for the day. If you guys want a question, have a question to ask me or something, I'm right here. And you can stay after class, but you can all leave now. Oh, did you need me to answer a question or something, Anya? Sorry. No? Yeah, I'm gonna stop sharing now because I do not know. Oh, yeah, you're still here. Okay. Hey, sweet baby. All right. I will see you Monday, guys. Take care. Okay. Mhm. All right, I see that you finally connected to the, nope, still not connected to audio. Okay, still connecting. Okay. Hey, pretty girl. Thank you. Having a hard time connecting? Yeah, I know. Okay.